Dr. Devdas Lata. He is really a towering personality. You will know as I read out Sir's biodata. I feel honored to introduce to you Dr. Devdas Lata. He has done his PhD on some investigation on the performance of dual fuel diesel engine with hydrogen and LPG as secondary fuels. He has 20 international publications of 20 international journals to his credit. He has written book on investigation of dual fuel diesel engine with hydrogen and LPG, ISBN number 978-359-15025. Two book chapters, two national journals, have made presence felt in 6 international conferences. Sir has got participation in 10 national conferences. He has got many sponsored projects. 2 projects have been completed in which he held the position of co-investigator in one and principal investigator in another one. There are 2 ongoing projects also. He is having editorial board membership in carbon science and technology. Sir has organized international conference on alternative energy sources as organizing secretary. Sir has also organized 2-day workshop on advances in automobile engineering as organizing secretary. His experience include lot of institutes and colleges, starting from Nagpur Polytechnic College, then General Reserve Engineering Force, Kirloskar Oil Engine Limited Pune, Maharashtra State Road Transport Corporation, SVPMS College of Engineering Malegaon, SVPMS Institute of Technical and Engineering Malegaon, Birla Institute of Technology Misra Ranchi, to name a few. Sir has been instrumental in laboratory developments, specifically in hydrogen energy laboratory, solar biomass, cold storage plant, to name a few. He has got additional responsibility, like he has worked as Deputy Controller of Examination, Birla Institute of Technology, Misra Ranchi from September 2011 to October 2012. Presently, additional responsibility of Warden of Research Scholar Hostel. He also happens to be Secretary of Birla Institute of Technology, Consumers Cooperative Stores Limited and Secretary of BIT Staff Club. Now, I would like to hand over the session to Dr. D.B. Lata, sir. Please, sir.
Thank you, sir. Thank you. Thank you. Good afternoon to all.
Good afternoon, sir.
Good afternoon. Good afternoon. The topic of my today's session is that the performance of dual fuel diesel engine with hydrogen as secondary fuel. Here I just said what the state is, why we go for the hydrogen at the moment. Why we call it be a dual fuel. And why we call it be a why we call be the secondary hydrogen as a secondary fuels here. One basic things I would like to explain you first. The title of this session is that hydrogen nowadays are used as a clean energy sources, because after combustion of the hydrogen, it convert into water. And from water we get the hydrogen, and from hydrogen after combustion we get water back. So hydrogen as a energy sources comes under the heading of the clean and green energy sources. Now what happens in case of the diesel? Why I just say about the diesels? We already know that the energy demand is approximately double within 50 years of time. About 2/3 of the energy demand of the world is fulfilled by petroleum and natural gas. That you all aware about these things, because it is easily available and it is easier to, and it convenience also to handle this type of the conventional fuels. Now, second effect of this fossil fuel causes damage to the environment because of this fossil fuel what we are using at the moment. We can call it like gasoline or diesel or gas. It creates it liberates the pollutions, and before the fact it damages the environment. Main constitutes of this Main constituents of these fossil fuels are carbon, hydrogen, and small amounts of sulfur and oxygenated additives. These constituents produce various gases like CO2, SC, unable hydrocarbons, carbon monoxide, nitrogen, nitric oxides, we call and particulate matter with some soil, as some organic compounds. These are the outcome of this pollution, which is up to get after the combustion of these fuels. Now, if suppose we want to overcome all these problems, what are the alternative sources available with us? If you think about that, if you see about the current scenario, you have heard about that the government of India has asked to convert their vehicle in the areas of Bharat 6, that we call the Bharat 6 or 06. Bharat 6, it makes the pollution norms very stringent. Now, if suppose these are the pollutants which is coming out from the after the combustion of these fossil fuels, the CO2, the CO, and all, these are definitely harmful to the human. It is definitely affect our greenhouse effect. It creates the greenhouse effect. So, what be the alternative solution for us in case of under the heading of the research areas, or what modification we can do for the the first alternative sources are that we go for a common rule diesel injection system. We already seen about nowadays. Some year before you observe that we are having the individual pump system in case of the diesel engines. Correct? So, and now since from the 4 to 5 years, all the vehicles is now converted into CRDI, common rail diesel injection. This is the modification of the earlier injection individual pump system. Second, nowadays, you already observed that in case of the petrol engines, earlier you observed that it was a carburetor through which the petrol is supplied to the engine. Now, since 2000, after the 2000, the carburetor version has been mobilized, and in place of that, the multi-point fuel injection system (MPFI) is introduced into the system. So whatever the vehicle available in case of this multi-point fuel engine system is available in case of the petrol engine or gasoline engines. So this is the second modification we are doing. This is the second modification we are doing. Now the third modification. If you see the vehicle during the mode of the 2021, suppose you see the latest what we call the Kia vehicles, what we say the advanced model, this latest version of the Creta petrols. You observed it, particularly this Kia vehicles, Kia, what we call the Sonet or Seltos. In the Seltos vehicle, what they did now, they have jumped from the NPFI system to the GDI system. GDI system is what? Gasoline direct injection system. At present, the Kia, MG Hector, or the latest version of the Creta, it introduces this type of the factor, gasoline direct injection inside the cylinder, so that it controls the more amount of the pollution. All we are doing in respect to the pollution which is coming out from the combustion of the diesel or combustion of the fossil fuels. Now, after that, what they change it, lean burn and charge stratifications. This is the new concept nowadays. The people are working, researchers are working on these areas of lean burn and the charge stratifications. Correct? This is under progress. You may be after within a year of 2 or 3, you may get such the vehicles are having the lean burn and the charge stratification. Now, after that, what type of the improvement they have done it? The improvement in fuel quality. They also improve the quality of the fuels. What like that? They create the low sulfur diesel that we call the LSD or ultra low sulfur diesel ULSD. In the case of the fuel, we can have the low sulfur, ultra low sulfur. Now, the advanced emission technology, such as diesel oxidation catalyst, we are introducing this factor into the system. And advanced emission technologies such as diesel oxidation catalyst, diesel particulate filters, selective catalyst regeneratives have been developed. These are the some of the factors in respect to the emissions. You already observed that these are the this diesel particulate filter or slate to catalyst regenerative system. They are introduced this in the from the exhaust valve to the silencer. In between this tip system is attached, particularly the exhaust system of the engines. So that the pollutants which is coming out to the atmosphere, they are having the less pollutant effect. Now, the next title of my this is the concept of dual fuel engine. Now, the idea is that what do you mean by dual fuel engine here? In dual fuel engine, both type of process exist simultaneously. Now the question arises, what type of the process I am talking about? Means both type, which both type I am talking about. That is the carbureted and in dual fuel engine, and that is a carbureted mixture of air and high octane index gaseous fuels, which is compressed like a regular diesel engine. Means what happens? Carbureted mixture of air and high octane index. These gaseous fuels are high octane index numbers. And then if suppose these gases are used, they should be carbureted mixture of the air and these gases are supplied to the engine, just like in case of the normal working is there. Advantage of this type of the engine is that it utilizes the diversity in flammability limits of two different types of the fuel. Now, what my question is that, do you understand the meaning of the flammability limits here? What I say that advantage. We are having the advantage of this system in which we utilizes the diversity in flammability limit of two different fuels. Is what happens now we observe that in case of the dual fuel engine, we are using the dual fuel. One is the gaseous form, second is in the liquid form. That's why we call it be dual fuel. Not be a hybrid. This is the mixture of LPG and the mixture of hydrogen and air is the one gas, and another gas is that of the diesel. That's why we call it the dual fuel engines. Now the diesel is having different flammability limit, hydrogen is having different flammability. So both the flammability limit we can use in this dual fuel diesel engines. Now gaseous fuels like we can use the gaseous fuels like CNG, LPG, biogas, producer gas, hydrogen, and fumigated liquid fuels like gasoline, methanol in air are used as a secondary fuels. What I'm talking about is fumigated liquid fuels like gasoline. If suppose we can fumigate the gasoline, we can use this fumigated gasoline fuels as a one of the sources of and one of the energy sources. Along with the diesel, means we can use the gasoline vapor also, fumigated gasoline. We can use the diesel also. That's why what I talked about earlier, lean burn and charge stratification. In case of the charge stratification, we are using some part of the fumigated liquid gasoline and some part we are using the diesel. So in case methanol is also we can use it as a secondary. Now, so many options are available now in front of us. We can use CNG also, LPG also. Nowadays, if you see in the case of the Delhi structure, you have seen that all the commercial vehicles or all the buses, transport vehicles are they have shifted to the CNG. Means what the diesel vehicles which were earlier running, they converted to diesel engine, the CNG. What modification they did? They doesn't make any sense. They in place of this injector, they place the spark plug there, and the gas is supplying as it was supplying. It is normally supplied in the form of the carbureted mixture. Now, if the CNG, LPG, or you can say the LPG you can use in case of the petrol vehicle. If you see the hybrid vehicle, you observed that earlier, they can use on the basis of this LPG gas and on the basis of the petrol fuel also. We substitute the petrol fuel by LPG. You've seen so many vehicles lying on the road which are having the LPG more now. Biogas, you already know that we can use biogas also, we can use producer gas also, and hydrogen. Along with all these gases, the hydrogen is certain advantages. What advantage it is that? The hydrogen is the lightest element in the periodic table. First, this is the one important part of it. Lightest element is the lightest element. Hydrogen require minimum ignition energy to ignite, but has higher self-ignition temperature. Hydrogen require minimum ignition energy to start, to ignite. But what happens, the self-ignition temperature of hydrogen is much higher than the diesel. So, because of this high compression ratio, in case of the diesel, the hydrogen cannot burn by its own. We have to have one ignition sources to ignite this hydrogen. This is the again the plus point of view. Now, combustion dual fuel design. How the combustion takes place in case of the liquid fuel and the gaseous fuel both are simultaneously available in the engine. Now, it consists of diffusive burning of diesel fuels and homogeneous burning of gaseous fuels, which strongly affects each other. If you know about the this burning of this, how the combustion takes place in case of the pure diesel or pure petrol, yeah. Suppose if I ask you one question, or if you that which type of the combustion processes takes place in case of the petrol engine or gasoline engine or in case of the diesel engine. Or we can call the auto engines or the diesel engines. We can say like this also. You know the basic difference between the auto engine and diesel engine. In case of the auto engine, it is the mixture of fuel and air in the homogeneous form. While in case of the diesel, it is the heterogeneous mixture of the fuel and air is there. So that this is the basic difference of this. One is homogeneous, second is heterogeneous. Now, in this case of this dual fuel engine, we are having the advantages of both. The mixture is heterogeneous in nature also, mixture is homogeneous in nature. Both this type of the property of the both auto and diesel we can utilize in the case of the dual fuel diesel engines. That's why it is said that it consists of diffusive burning of diesel fuel and homogeneous burnings of gaseous fuels which strongly affects each other. Now next that it shows combined aspects of diesel and auto cycle. I already explained you combustion process along with unique features of dual fuel. It has one unique features also. We can see in just later on. Now, if you see about the proper combustion processes in the petrol engines or in case of the diesel engines, what the it consists of the four processes. If you plot the figure in between the pressure and crank angle, the pressure means how much the pressure is developed inside the cylinder with respect to the moment of the piston inside the cylinder that we call the moment of the crank angle. At the different crank angle, different position is there, different position of the piston, different pressure is there. So, in case of the normal conventional diesel engine, there are exist the four processes of combustion. First, the ignition deliberate. Second, premise combustion rate that we call the uncontrolled combustion also. Third is the control combustion process, and the final is the afterburning. These are the four processes are available in case of the diesel engine. Normal diesel engine, correct? Now see this figure. This is the pressure, how the pressure is check place inside the cylinder. This is the crank angle. This is the crank angle. By with the crank angle, we can show that this crank angle indicates the position of the piston inside the cylinder. Correct? This we call the top, this line, this straight line, vertical line, the zero. Zero indicates the top dead center position. Top dead center position is what? Maximum position of the piston in the topmost level. That we call the topmost positions. Correct? So this zero and minus sign indicate that the piston is about to reach to top dead center position. A plus sign indicate that the piston is moved downward. On the left hand side, piston is moving upward. On the right hand side, piston is moving downward. Correct? So this each having the different processes. I think you know all the basic processes of the diesel engine or the petrol engines. So what I have drawn here at the angle of the minus 100 means if suppose piston is at the bottom of the center position, what bottom center is position is what? At the lowest position of lowest position in the center cylinder. This process, when the moment of the piston takes place, we call the process is the compression process. The compression takes place, the pressure of the air and mixture get increases. The air of in case of this diesel engine, the pressure of the air get increases. Means the one process from piston movement from the BDC to TDC with the crank angle is covered 180 degree. The moment of the piston traveling from BDC to TDC, the crank angle travel is the 180 degree. So after at a position of the minus 100 degree, at a position of the 100 degree, not complete. If it reaches to top center position, it covers the 180 degree. So go minus 100, then it moves 80, then 60. In 0 bits, then topmost positions, topmost position of this crank and pistons. So these. So now what happened? That the pressure increases as the piston is moving from VDC to TDC because of the compression takes place inside the cylinder. Due to compression, the pressure and temperature also both simultaneously. The pressure increases at point A, means pressure before the piston just top the center position. Suppose this is the point 30 degree, this is the 20 degree, 30 degree. When piston is reaches to 30 degree angle prior to the top center position, or that we call it be a 150 degree centigrade, 150 degree angle. At that position, we start the injection of the point A is the point of starting of the injections. While the part B is called the start of emissions. As soon as we supply the fuel, the combustion does not start. It takes certain crank angle. Correct? From A to B, that's why we call it B initial delay. Because at point A, we start the supplying the fuel, but it does not ignite it as immediately as the fuel is inserted into it. It takes certain time. That time from A to B crank angle, the time is maybe milliseconds, but some crank angle is there. The moment of the piston is takes place inside the cylinder because of that water plant, the combustion takes place at point B. So point A to B that we call the time lag or ignition lag. Now from B to C, I already explained you in the previous slide that the first is after the second stage is the previous combustion or uncontrolled combustion. This BC is nothing but the previous combustion or uncontrolled combustions. Means whatever the fuel accumulated inside the cylinder, the combustion takes place instantaneously. That's why we call it be a uncontrolled combustion. We do not have any control over it. Now C to D. The first phase of combustion already started at point B and it continues up to point C. Means that we call the uncontrolled combustion. What happens after C? We the inside the cylinder, the combustion already started, but still we are supplying the fuel inside the cylinder. And from C to D, that's why we call it be a diffusion burning. That's why we call it be a diffusion burning or controlled combustion. Now D to E is nothing but the after burning. Some of the fuel get burned and some of the fuel get left inside the cylinder. That is the combustion takes place after the top dead center position. With the top dead center position, the piston is moving downward. And the piston is on the process to move towards the bottom dead center positions. During that time, this is the after burning takes place that we call the D2E. The after burning is there, then they go to the exhaust and all the things. Whether subsector, model, so this is the normal combustion processes. On the other hand, the combustion in dual fuel diesel engines using pilot diesel fuel as an ignition source occurs in five stages. Earlier we are having the 4 stages. Now in here we are having the 5 stages. First is that pilot ignition delay, what I already explained you, whatever the delay is there. I used the word pilot body here. Correct? It was not in the previous case. Pilot fuel means why we call diesel as a primary fuel or the pilot fuels? Because these diesel fuel are used to start combustions. So diesel fuel can ignite it first, then they ignited the whatever the hydrogen gas is available inside the cylinder. Then they ignite it. Because I already told you that hydrogen is having the high side ignition temperature. Because of that, it does not ignite by its own. We require certain ignition sources. In this case, diesel we are using as the ignition source. That's why we call it here poly diesel. Right? That's why we call it be a poly ignition delay. Means what? The ignition delay of the diesel fuel. What is it? Means that ignition delay of the diesel fuel. Second, what there? Pilot pre-mix combustion. Pilot what is there? By pilot means what? Whatever the fuel is there, the combustion pre-mix combustion takes place in the diesel which is accumulated inside the cylinder during the period of ignition delay period. Then this is the then another ignition delay is there that we call the primary gaseous fuel ignition delay. Means what? Now the question is the gaseous fuel ignition delay. These gaseous fuels have higher temperature. It takes its own time
Sir,
to
sir,
ignite.
sir, sir, sorry to interrupt, but you
Yeah.
need to charge your battery because it is only 10% remaining, otherwise it will end up. And if
Thank you.
possible, kindly make your presentation full screen.
Thank you.
Okay, sir, it's only 10% left now.
Yeah. Thank you. Thank you. Now see it. Now, A to B is the pilot fuel ignition delay, just like in case of the diesel. Diesel already takes certain time to ignite. So A to B is the ignition delay of the diesel. B to C is the pilot pre-mix combustion. Okay. So B to C. Now C to D is the further ignition delay of the gaseous fuel. Because gaseous
Sir,
fuels have
sir,
higher
can you
ignition
make
temperature.
sorry to interrupt, sir.
Hello.
Can you make it full screen? Can you make it full screen, sir? Presentation, your presentation. Slideshow.
Okay, I got it.
Okay, sir.
It's now good. It's okay. Now, see this A
Now
to
it's okay.
B. Okay now?
Yes, sir. Now it's okay.
A to B, I already explained you the ignition delay of the diesel fuel. B to C is the premise, pilot premise combustions. C to
Kindly
D,
press
the
F5, sir. Kindly press F5. Kindly press
what sir?
F5. Kindly press F5. So it will be full screen in slideshow. Okay, sir. Perfect.
Yes, sir. It is visible in full screen.
Please continue, sir.
Now, C to D is the C to D is nothing but the ignition delay of the gaseous fuel. Because I already told you, gaseous fuel also already have certain high temperature, say ignition temperature. It takes some time to ignite. Now, D2E is the diffuser burning of the diesel fuels and the gaseous fuels. E to F, again, the after burning is there. That's why E to B one phase of combustion, second, B to C second, C to D third, D to E fourth one, and the E to F is fifth one. So, because of this, we are having the The five stages are there in case of the dual fuel diesel engines. Now, now, in principles, there are three behavior of compulsions that follows in series in dual fuel diesel engines. One by one in the following series in case of the dual fuel engine. First combustion process is the single combustion. Second is simultaneous combustion. Third is the successive combustion. These are the three stages, basic stages of the combustion. And after burning, we do not get a much power out of, in the case of the after burning. We do not get a power from the ignition delay, so we are not contributing into it. When the combustion started from point B onwards up to the point E, these are the things. In case that there are the three phases of combustion in between the B to E, B to C, single combustion, C to D, ignition delay, the simultaneous combustion, and the successive combustion. These are the three phases of the stages of the combustion takes place in case of the dual fuel diesel engines. The dual fuel engines have more advantages than diesel engines. In dual fuel engine, no modification in hardware is required in existing engine design. Whatever the design of the engine is there, we do not need to modify it in excess. Another advantage is that it is flexible of flexibility. Means we can switch back to pure digital mode as and when required. As if hydrogen is not available, we can directly shift to the digital without any effort, without any modification done into the engines. Now the problem related with the dual fuel engine is poor utilization. There are some problem also with the hydrogen or dual fuel engines. What problem is there? Poor utilizations of the injected fuel at light load conditions. At light load condition, the poor utilization of the fuel is there. While the loss of combustion control at higher load condition. At light load, poor utilization is there. At higher load, the loss of control, which the knocking problem is there. So these are the one drawback of this. Now, if you go for the review of this system, we already have this so many cases I already explained you. The CNG, I just tell you, CNG is the already used in the transportation for several parts of the world. The automobile industry have now introduced dual fuel petrol car operated on LPG and petrol. This is not only reduces air pollution but also reduces the operating cost. You already know about this LPG nowadays using the petrol car. The earliest experiments on dual fuel system were performed by it was already since from 1929 the LPG are using in the case of the automobiles. Though during the 1929 and the 1930, the dual fuel engine was not used in commercial due to its mechanically compressed. During the Second War, scientists in Great Britain, Germany, Italy had paid more attention to the appropriate fixture of dual fuel engines in civil and military areas. Elliott and Davis studied the effect of gaseous air mixture strength on the performance of dual fuel engines. Correct? Now, what about the CNG? It is the mixture of the several gases. Compressed natural gases is the mixture of the several gases with methane as a primary constituent. About 85 to 90% of the methane is there in case of the CNG. The remaining constituents include methane at an average of 78% and other methane about this. It is extremely low photochemical activity, zero UV emissions, and reduce low temperature emissions due to removal of cold start enrichment. Correct? Now LPG. It has higher octane in the index number and combustion of LPG takes place practically in uniform fuel air mixture. Propane and butane gases have the higher heavier than air. The most dangerous fact associated with LPG is that if LPG is leaked and gas mixed with the air, the mixture temperature reaches to the 500 degrees centigrade, it was explosive. The biogas, we already know about the biogas. Biogas is the reach of the 55 to 70% methane is there, and some part of the hydrogen sulfide, the carbon dioxide, and some part of the hydrogen also be there. The presence of hydrogen sulfide, water vapor, and halogenated hydrocarbons also worsen the quality of the lubricating line. Because of the presence of the hydrogen sulfide, water vapor, the quality of the lubricant oil get deteriorated. Now, the producer gas is a mainly mixture of the carbon monoxide, hydrogen, nitrogen, and carbon dioxide. It can be produced by partial combustion of the solid carbonious fuels, such as wood, charcoal, agricultural waste like rice husk, and coke in gasifier. It means we can produce the producer gas with the help of the rice husk, with the help of the coke, with the help of the agricultural waste, charcoals, wood. Now, what about the hydrogen? The hydrogen has all the desired quality of the unique fuel. All the what the fuel we require as having the all desired quality, which is likely to become an ultra clean fuel. Ultra clean, not only clean, but it's ultra clean. From various technical and ecological points of view, the hydrogen seems to be most suitable petroleum alternative in IC engines. Now, I would like to share one thing. Government of India on this, our Prime Minister, Honorable Vice Prime Minister, on 15th of August, they during their presentation, they already declared that the government of India also moved toward the hydrogen as a clean energy to be utilized in the combustion process of the automobile or in case of the industry. So already they consider hydrogen is a clean energy. Now they have created the missions to generate the energy from the hydrogens. It can be produced from any primary energy fuels, coal, oil, natural gas, all sort of renewable energies, and from electricity. We can use from any sources. We can use the hydrogens. Certainly, because of its environmental and climatic cleanness, hydrogen generation from renewable energy is the best solution. From the renewable energy, produce the hydrogen is the best solution because of the it creates the climatic cleanliness. Hydrogen is tasteless, odorless, non-toxic, and it produces clean energy and water vapor during combustion with air. Hydrogen does not have problems like vapor lock, cold wall pinching, inadequate vaporization, and the poor mixing. Okay. Now, these all I just compared all different properties of the other gases which is available for hydrogens, the low rating value. Now, see what here. 40 to 800. Lower heating value means this calorific value of this. Calorific value of this. What you observe, the 40 to 800, but nearby 43,000 calorific value kg per kg, kilojoule per kg. So LPG we are having the 46,000, CNG 47, producer gas 3,500 to 6,000 only, biogas 20,900. In case of the hydrogen only, it's down 1,20,000. So much energy is lying in the hydrogen, 1,20,000. Or what about the other 42, 46, 47, 6,000 only, 20,000 only, and is having the 1,20,000 kilojoules per kg of energy we are getting out of. Correct? In this case also, low rating value, if you see what low rating value, 25,000, 2,000 only, hydrogen is the 2,000, in the CNG 36,000. In the case of the volume, and neutron metric. Correct? Emission temperature, we can see auto emission, the flammability limit, 0.6 to 7.5. LPD 2.1 to 9.6, here 4 to 75. Means in volume, percentage volume in air. If suppose hydrogen is available in the 75% in the one mixture of the fuel and air, still it can ignite, but the other fuel does not get ignited. In case if the percentage of only 4% of the of hydrogen is available in the atmosphere or in the cylinder, still it can burn. So these are that's why we call it the flammability limit. Then how we can, because performance is means what? How we think the performance that this hydrogen is useful. How we compare the dual fuel engine with the it gives better performances not by going through the experimental work. So we also did the experimental work over it The engine which was used the four cylinder was the four cylinder diesel engine coupled with a 62.5 kilowatt hour and a generator. Each is equipped with the inner four cylinder vertical drag engine of turbocharged with intercooler. We use the engine turbocharged intercooler. The rated power output is 25.5 HP, 1500 RPM. The dialog test facility includes the following arrangement. Current the way I need some element is there in the case of this. So this is the hydrogen cylinder. This is the flame trap. This is the flame arrestor. Then the hydrogen it goes to inside the. This is the air inlet. From here, for the air inlet system. From the air inlet, the air is coming from this side. The hydrogen from the 15, it goes to the system. They made mix with the air which is coming out from through the inlet manifold. And this picture is goes to the engine. The engine is there. And from engine, it goes to the exhaust is there, which coming out from it. We can use the exhaust emission method. How we measure the exhaust. So these are these are the setup of this. Correct. So save in the computer, whatever the data is there, the data is supplied to the computer. From computer, we get the readings, all the things. So this is the basic this is a basic arrangement of the hydrogen system. Now, what there? This is the hydrogen. Red one is the hydrogen cylinder. Correct. From this hydrogen cylinder, hydrogen is coming. The Now, hydrogen is coming to this flame trap. This is the flame trap that we call the hydrogen flame trap. From hydrogen flame trap, where it goes to the meter. We are measuring the amount of the hydrogen we are supplying into it. This is the mass flow meter of the hydrogen. Then this is the engine in which we are supplying it. This is the flame arrestor, the blue one. This blue line is the pipeline through which the hydrogen is coming and inserted into the engine. और ये देखो ये inlet manifold है ये देखा this is the inlet manifold. We are injecting hydrogen in the inlet manifold, and from inlet manifold hydrogen goes to the engines and the engine gets started. This is the pressure transducer charge amplifier. This is the four cylinder 1, 2, 3, 4. This is the pressure transducer is there in between it. Correct. This is the in that form of it. How we did the experiment over it. First, we ran the engine with the help of the pure diesel only. What were the performance of the diesel engines? Diesel engines shows we can note down about with respect to the fuel consumption, with respect to the load, with respect to the pollution which is coming out with, all in respect to diesel. Then in respect to the diesel plus hydrogen. So one only engine runs with the diesel engine only. In case of the case two, engine runs on diesel as a solid fuel and hydrogen as a secondary. So in the second case, hydrogen is also be used as a secondary fuel, while in case one, the only diesel we are using as a fuels. At what load percentage we are using the diesel and hydrogens, or how much the percentage of the hydrogen we are supplying, from 5% to 50% hydrogen we are supplying. If suppose why not we go more than beyond 50% of the hydrogen? Because if the percentage of the hydrogen intake is more, then the problem of the knocking arises. The problem of the knocking is more, hence we are restricted the percentage of the hydrogen up to 50. Otherwise, what happens? Knocking damages the engine, so that it is not never desirable. These are the different trials are there. Now, this is the diesel I am just seeing. How the spray text inside the cylinder. Is the six holes are there? Three on this side, three on this side. Six hole diesel supply is there. How the diesel goes inside the cylinder. This is the way the diesel goes inside the cylinder. Now, when the diesel goes to the intake, so I just make it a pictorial picture of the diesel. This is the spray of this is called the spray zone. is the diesel to be injected inside the cylinder? How the diesel gets separated into different zones? This is the center one of this elliptical shape that we call it the center is the core shape. It is the diesel is available in the diesel form. Now, surrounding to this, what happens? The part of the diesel get vaporized because of the heat is available inside the cylinder. The part of the diesel get vaporized. It is surrounded by the core fuel. For the premix diffuser reason is there, the vaporized fuels get mixed with the air, surrounded air which is nearby to the injector. So they are going to mix with it. After that, what happens? The propagation of the gaseous fuels will also be there. The gaseous fuel also get fire. And what happens? The gaseous fuels after burning of this is the propagation of the gaseous fuel air mixture. The air mixture it gets propagated inside the cylinder. The flame gets propagated inside. This is the portion. This is the end portion of the chart which is yet to be burned. Okay, that's why it is called the unburned gaseous fuel. As the flame it increases, moves from this to this side to this side. This gets compressed because of the high pressure developed by the combustion of the fuels inside the cylinder. Now, what this figure says that is the reactant, is the temperature. Reactant percent of the reactant getting reduces as the flame moves in as the flame front is moment of the flame front. Secondly, the temperature get increases. Pressure reactant, the percent of the reactant reduces, and but the temperature get increases here. Temperature get increases. Now what I already told you about the ignition delay. Then how we begin the ignition delay here? We can ignition delay nothing but the start of injection to the start of combustion. The gap between the start of injections and the start of combustion. That gap is called the ignition delay. Now, how we calculate that? That if fuel get start burning, how we know from the outside of it? So that is calculated on the basis of the this injector rate of pressure rise. So this is the injector lift short. Here the fuel supply tax rate, and this can the fuel supply tax rate. And at this position, at the minimum point of this position is used the start of combustion. And from this point, the start of combustion takes place with respect to the rate of pressure rise. In case of the heat release rate, what there, this point, this is the zero line, this is the crank angle, this is the net heat release, how much the heat you get released out of that. This net heat release from that, this point is called the point use this shows that the start of combustion at this point. So we can calculate the start of combustions by means of the rate of pressure rise also, and by means of the net heat release also. In this case, the minimum point is the minimum point, not minimum point, but the 0 point from here to here, 0 point comes, then the start of combustion is there. While in case of this, the minimum point of this is use the minimum point of this use the start of combustions. So that's why from here we can get the now thermodynamic analysis of that. You all this if you are the mechanical engineer, you just come to know that the polytropic index come to the picture because this process of the compressions is not isentropic. It a certain amount of the entropy get changes. So the so it means that the process is the polytropic. Then how we calculated the polytropic on the basis of the polytropic index. So we are calculating or finding the polytropic index of the situation or inside the air. Polytropic index we can measure from the start of combustion to the end of the compression. During the time of the compression process, we are measuring the slope of the process of compression. Use the polytropic index. So what we observed that polytropic index is one, there is the nearby one point more than 1.34 and just below the 1.36. But in all the cases of hydrogen and LPG, hydrogen plus LPG, we observed that the polytropic index get reduces. It decreases. It decreases. Polytropic index get reduces here. Now, how we calculate the linear regression analysis? We can mathematically also we can calculate the ignition delay. Correct? We can calculate the mean temperature developed inside the cylinder also with this formula. We can have the pressure, because of pressure transducer, we can have the pressure where we are having. With the help of the current angle position, we can able to calculate the this what we call temperature of the system or volume of the system. So we can calculate the temperature by means of the pressure and volume, and we can get the temperature inside the cylinder. What we observe that temperature, cylinder mean cylinder temperature get reduces as the gases to substitution where increases the gases to the polytropic index reduces because the polytropic index the the temperature of the gas also get reduces. You observe that the pressure also get reduces out of it working using the gases to it. The oxygen concentration, because we represent the air with the help of the hydrogen. So what are the effects of the hydrogen substitution in case of the oxygen concentrations? So what then you observe the oxygen concentration get reduced as the percentage of the hydrogen get increases. Of course, the addition of the hydrogen replaces the air because the quantity of the air supply inside the cylinder is less and the air supply is less, it indicates that the less oxygen is available inside the cylinder. Ignition delay what the ignition delay get after certain time ignition get increases, then it reduces. Correct? From the diesel get ignition delay get increases, then it reduces here. Now general discussions are there. For first performances, we can have the brake thermal efficiency. We are always concerned about this brake thermal efficiency because it gives the efficiency of the engines. So what we observe that brake efficiency as the load of the engine increases, brake thermal efficiency can increases. So this figure shows like that. The brake thermal efficiency can increases as the supply of the gas will increases. Now at low load condition, the brake thermal efficiency for the case 2. Case 2 means what? Case 2 means what? The mixture of the hydrogen and air. Then what indicate? Why indicate that the at low conditions, the brake thermal efficiency for class 2 as well as class 3, class 1 operations. At low load condition, a small polyethylene quantity makes a lead flammable results. Unburnt mixture gases in mixture and the rise in temperature of the unburnt charge in the burnt zone does not reach up to the solution temperature. Hence, reaction rate in the reacting zone of the flammable zone. Thus, gaseous fuel air mixture is practically oxidized in reaction zone where combustion takes place. Therefore, accumulation of unconverted gaseous fuels and carbon monoxide increases due to isotropic combustion. And these are the reasons why the performance are 80 happens to 80% load by performance of the 80% load is higher. At higher load, 80% of the full load condition, brake thermal efficiency of the case 2 means pure diesel engine is 10%, and 50% of history of fuel consumption is found in the informed case. And so these are the what we observed that 34.7% of the brake thermal efficiency is there and 30.6% of the compressed. So if you use the fuel, we are having the efficiency hardly maximum 30%. While in case of the gaseous fuels, the if you compare with the gaseous fuel, what you observe that the why this is so, this is due to large quantity of the polydiesel fuel that leads to a stronger ignition sources. This reduces delay period due to uniformity in mixture formations, which accelerate the pre-flame reaction and hence gives more complete and rapid combustion of the fuels. Because of that, the efficiency is more. VSFC, we already know that VSCC is the reverse of the brake power. Brake power efficiency increases, this get reduces. At a certain load condition, the brake specific consumption get low as compared to that of the diesel also. Now, brake specific energy consumption. The brake specific consumption is an important parameter to the performance of the engine, which shows its ability to convert fuel into work. At 10% of the load condition, the higher than the efficiency is 33% higher than the pure diesel engines. Mean at low load condition, the fuel consumption rate is 33% more than the pure diesel engines. This is we like to note. The temperature of the charge at the end of the compression is most critical parameter for initiation of the combustion is CI engines. The presence of hydrogen increases heat transfer rate and hence cooling effects are there. Cooling losses are more. The pilot diesel fuel does not get sufficient time to complete pre-flame reactions. Therefore, in order to produce the required power, large amount of the diesel was supplied. What I say that the fuel is the hydrogen we can control. Supply of the hydrogen is our hand, we can control according to the need. But what about the diesel? Diesel is automatically controlled by itself depending on the speed of the engine and depending upon the load on the engine. So it can be the amount of the fuel can automatically controlled by the pump there. So that's why here what they are mentioning the power diesel does not get sufficient time to complete pre-mix flow, pre-flame reactions. Therefore, in order to produce is suppose the sufficient time to complete pre-flame reactions. Now about the emissions, brake thermal efficiency, and about the brake specific energy consumption. Now, what you observe in case of the hydrocarbons, SC, you observe that the hydrocarbon at certain after certain low conditions, hydrocarbon can increase. Correct? What are the reasons? The hydrocarbons are developed because of the overdigging and undermixing are responsible for SC emission in direct engine. Correct? Hydrogen consumes air at a faster rate as it is previous form and has higher burning rate than diesels. This leads to significant consumption of the fuel and it consumes faster rate and the oxygen is consumed by the hydrogen so that the oxygen are available for the pilot fuels. Correct. These again the same graph is there. The carbon monoxide. What you observe the carbon monoxide? Carbon monoxide is that the carbon monoxide percentage after certain time get increases when the hydrogen is used. The same logic is there because of the formation of the carbon monoxide depends on post-oxidation reactions. For very lean mixture, some of the CO may not be utilized or oxidized further due to failure of combustion process. To cover whole charge and relativity, slow reaction process. These are the responsible factors for carbon monoxide production. Initially, the percentage of CO is reduced up to 20% of hydrogen and substitutions. Then it increases sharply at all low conditions. If hydrogen percent is low, then the CO formation is also low. The CO emission at 80% load conditions due to 20% of the hydrogen substitution is found to be this much. These are the values which are obtained after that. The higher concentration of the hydrogen and the gaseous air mixture become richer due to their replacement by hydrogen in the intake molecule. As soon as the ignition starts after ignition delay period, the spontaneous combustion occurs in two range of higher percentage of the hydrogen. Hence, the diesel fuel is further subjected to higher combustion temperature in an atmosphere of shortage of oxygen. This leads to fuel cracking and production of the carbon monoxide. The excess availability of the air, as in case 1, reduces the reaction rate due to reduction in the temperature. This CO, they are the result of this is the NOx, how the NOx formation takes place. HO2 plays important role in enhancing the conversion of NO2 NO2. What HO2? HO2 radicals can be formed by H plus O2 plus molecules. Use the HO2 plus HO2 rich mixture reacts with the NO molecules with high temperature combustion regions and enhances formation of the NO2. So NO2, what we can obtain, then the HO2 rich mixture reacts with the NO molecules. HO2 rich mixture or NO molecule which from the high temperature combustion regions and enhances the formation of the NO2. At a suitable temperature, the unburned fuels containing of hydrogen and could oxidize in the presence of CO2 and form HO2. These are the processes by the formation of the NOx inside the cylinder. No form in the flame zone can be converted to NO2Y. Why? क्यों नहीं होता है भाई सर? As a result of negative activation energy and low concentration of the HO2, the rate of NO2 formation changes very slightly and is in spite of the substantial increase in other concentration of the NOx. The distinction of the NO2 to NO make clear of this. And from this, the NO2 plus O is from the NO plus 2. NO2 is equal to 1 plus this. So these are the equations they are using for them. NOx formations, we already seen about the NOx formations there. Already there, NOx formation is reduces. Now smoke. In all the cases, we observe the smoke get reduces when we use the hydrogen into the system. Because no carbon, hydrogen does not contain any carbon. There is no question of the formation of the NOx industry. Smoke basically consists of combustion generated carbonous materials. Combustion generated carbonous material like soot on which some organic compounds are organic. This is the important part of it. It is from incomplete combustion of the hydrocarbon fuels and some amount of the lubricating oil. The heterogeneous and the diffusive mode of combustion are responsible for making formation of the reactions. The heterogeneous and diffusive mode of combustion are responsible for the smoke formation diesel engines. The smoke formation increases with load and ignition ratio. Dual fuel operation reduces smoke by around 30%. 30% of the smoke can be with the help of the hydrogen is there. Now, there are certain areas, certain parameters that we call the combustion parameter. It depends on the how the combustion takes place inside the cylinder. All these properties. What they ignition delay, vacuum rate of pressure rise, peak cylinder pressure, net heat release rate, heat release rate in the first phase of combustion and combustion duration. All these are the combustion parameters. And now we are going to see one by one here. We already discussed about ignition delay. Ignition delay get increases initially. And this the what? The formation of the intermediate compounds during compression process due to partial oxidation of gases will air mixture. These are the reasons why ignition delay get affected and more than the diesel engine operation because of the formation of the intermediate compounds. At the time of the compression process, mixture of the air and gases which are compressed, the pressure and temperature of the hydrogen get increases there, and they form certain intermediate compound. This is caused by the loss of very reactive OH radicals in the reactions with molecular hydrogen, which gives less reactive species that are not capable of accelerating in the reactions at the same rate as that of OTT. These are the reasons of the ignition delay there. Ignition delay, the loss of the OH radicals, the heat transfer rate to the combustion chamber center wall in case of the hydrogen substitution is more due to higher thermal conductivity. Hydrogen gas also having the high thermal conductivity, because of that, heat losses also be more. Now, this is the rate of pressure rise. This graph is belong to rate of pressure rise. The major rate of pressure rise here is the hydrogen substitution. The major rate of pressure rise is somewhat similar to diesel, but after at a higher substitution of the hydrogen, the rate of pressure rise get reduces. It gets decreases. एक मिनट रुकना जरा, मेरा बैटरी डाउन हो गया फिर से. लाइट यहाँ लाइट चली गई है, लाइट का प्रॉब्लम इज देयर, नो इलेक्ट्रिक कनेक्शन इज देयर. The battery of this can I please earlier, because the problem is there in the case of the battery, I think so. The light connection is not here. Electricity problem is going on. हाँ
Okay, sir. Okay, sir. No problem.
वो बंद ही हो गया होगा. एक मिनट, I can go through this. One minute here, some problem is going on there. One minute here, 1 minute.
No worries, sir. Take your time, sir. No worries. Yeah, dear participant, our speaker is trying to reconnect. There is a power failure at his place, so we will wait for some time. Thank you.
Dear participants, attendance link has been kept in chat box. So in the meantime, you can fill up that attendance link by the time speaker joins. And please stay connected. Am I audible?
Yeah.
Participants are requested to stay connected. In the meantime, you can fill up your presence of session 3. Thank you.
Amit sir? Hello,
Yes, yes,
Amit sir.
yes.
Yeah, the guest is Mr. Devdas sir is again joining with his laptop. So you'll make need to make him the presenter again.
Okay, sir.
Okay. Yes, sir. We can see you, sir. We can see you, but you need to connect your laptop again. So you need to unmute yourself from your device. Sir, Devdas sir, your laptop has logged out. So you need to connect your laptop also. If you are connected to us with your mobile, right? You need to connect your laptop also so that we can see your screen. Sir. Yes, sir. We can see your presentation, and you need to unmute from your phone. आपके phone से आपको unmute करना पड़ेगा. Then we will be able to hear you also. सर आपकी ऑडियो डिवाइस जिससे आप कनेक्ट हुए हो सर उसको आपको उसमें से आपको अनम्यूट करना पड़ेगा. देन वी विल बी एबल टू हियर यू. वी कैन सी योर स्क्रीन नाउ.
Okay, sir.
Yes, sir, we can hear you. Now we can continue, sir.
I started playing.
Yes, sir, we can see your screen. We can see your, we can hear also. And just a request that you make your screen, presentation on a slideshow, the full screen.
Yeah.
Yeah, press F5 or select slideshow, sir.
Okay, sir.
हाँ सर, विंडो सर पूरी कर दीजिए और स्लाइड शो में चले जाइए नीचे.
हाँ, चलेगी.
हाँ, कस्टम साइट. yes sir, done. Okay.
Thank you, sir. Sir, we are talking. Sorry for that, sir. For electricity problem, it was happened. Sorry for it,
No,
sir.
no,
I'm
that,
really for it.
no. That's okay, sir. You can continue, sir.
Now, the one thing is that I'm going to discuss with about the maximum rate of pressure rise. What you observe that here, just what you see that this is the diesel. This is the zero line base spot. The only pure diesel is there. This is the substitution of hydrogen is there. What you observe that as the substitution of hydrogen increases, the rate of pressure rise also get increases. This is the 10% load. This is the 80% load condition. Yeah, initially the rate of pressure rise increases as the hydrogen substitution increases. After certain period, after 40% of the or the 30% of the hydrogen substitution, it dropped then. It drop in takes place in the rate of pressure rise. Right? Now, at a lighter load condition, the delay period increases. At a light, why it is so? At a light load condition, delay period increases. As a result, gaseous fuel entrainment and accumulation of diesel also get increases. Miss what I said to you? This is the light load, 10% load condition. Here it increases initially. Why? Because of these regions. In case in case of the hydrogen lighter load condition, due to smaller pilot diesel fuel injection rate, the rate of heat release in first phase of combustion does not change very much and hence higher rate of pressure rise. Correct? The temperature of hydrogen air mixture at the point of diesel injection is higher due to higher concentration of the higher hydrogen and higher load conditions. What there, if you see that at a higher load condition, percentage of the hydrogen is also more. Because of this, what happened? The diesel injection is higher rate concentration of the hydrogen and higher load conditions, which will lead to greater vaporization and dispersion of the pilot fuel because of the rate of pressure is decreases at a higher substitution of the hydrogen. These causes reduction in the ignition delay. Because of the ignition delay also get reduces. And because of the accumulation of the hydrogen also get reduces. And hydrogen entrainment in diesel spray zone and thus lower rate of pressure rises here. Right? Now peak cylinder pressure. How much the cylinder pressure is how much highest pressure develop inside the cylinder. Now see that. These are all are the graphs of hydrogen. 10% hydrogen, diesel. Black one is the diesel. You observe that the 10% hydrogen, 20% hydrogen, 30% hydrogen is a 10% load condition. Load is low. You observe that as the rate of pressure rise is more, the pressure is also more in case of the low substitution of hydrogens. Right? At the low load conditions. At 40% condition, what do you observe that? This is the diesel, pure diesel. The rate of pressure rise is the peak pressure is more here. Peak pressure in case of the hydrogen substitution is more. Means pressure is developed inside cylinder is more when you use the hydrogen at a 40% load conditions. Now, what about the 80% load conditions? Now you observe that in the 80% load combustion, what happened because of the lesser ignition delay period, this diesel is this is the diesel line, and what about the this 40% this hydrogen, 20% hydrogen, and 30% hydrogen, and here you just observe that 40%, 45%, 50% hydrogen. You observe that the pressure 40 to 45% the pressure peak pressure inside the cylinder is reduces is less than the diesel pressure. Correct? So this is because of the less reduces in the ignition delay period. The peak pressure inside the cylinder also can reduces. The engine is running very smoothly then. Correct? Now peak pressure is the you observe thing. Is the pure diesel This line is pure diesel line because 0% gaseous fuel is there. The hydrogen substitution is there. As the hydrogen substitution is what there, the hydrogen this what you have, this is low load condition. This is the higher load conditions. As the load increases, as the load 80% load condition there, as the hydrogen substitution increases, the peak cylinder pressure get reduces. Yeah, the peak cylinder pressure get reduces only because of the reduction in the ignition delay period. Ignition delay period plays an important role in case of the this pressure, peak pressure rise also, in case of the rate of pressure rise also. Now, how much the heat get released out of the combustion of this? Correct? Now, I already told you that there are the three phases of combustion, the single combustion, successive combustion, and the simultaneous combustion. Now we can see here, in case of the net heat, how much the heat get released out of it. Now we will see it. These are the heat release processes there. How the heat get released out of the cylinder, inside cylinder. Now this is the diesel. This black one is the diesel, pure diesel. This is the 40% hydrogen, red one. This is the 25%. This is the 50% hydrogen. So what you observe there, the net heat release in case of the hydrogen is reduces because the quantity of the solid fuel is less and the quantity of the hydrogen is more there. Now you see the three phases of the combustion in case of the fuel. This is shown very clearly here. At 80% load condition, load is more percent of the hydrogen also be there, 30%, 40%, 45%, 50% hydrogen is there. Now you observe that. If you see about the blue one, we just mark about the blue one, 45% hydrogen, you observe that. This blue one, this blue line is there. This is the start of engine combustion is there. Start of engine combustion here, this point, 0 point, start of combustions. Now, this is going to be first phase. Now, this is the start of combustions. From here, it goes up. Now, the first phase, drop in again. From this to this first phase of combustions. Again, it moves up. And again, it drops. The second phase of combustions. Now, the third one is the third phase of combustions. Is the third phase of combustions there. So, in case of the dual fuel, at a high load condition, high substitution of the hydrogen, we clearly distinguish the three phases of combustions. While in earlier cases, we only have the two phases of combustions there, just like it. Just to see about this black one. This black one is diesel. In case of the diesel, only this drop is there, only this move up, again it is moves up. So this is the only one big phase, and the slightly second phase is there. While in case of the diesel, dual fuel, we are having the distinctly three phases of combustion is there you are observing here. Now, the first phase of combustion, premix burning of the part or whole of the solid quantity plus a small quantity of the gases to be retained in the spray. Second phase of combustion, auto ignition of the gaseous fuel, air mixture, in the closed vicinity of the solid spray, and diffusive burning of the remaining diesel fuels. And the third is the third phase of combustion, burning gaseous fuel air mixture by flame propagation. Correct? I already told you in earlier slides what I said that both combustion processes there. In case of the petrol engine or in case of the auto engine, the mixture is homogeneous and the flame is propagated inside the cylinder. While in case of the diesel engine, the mixture is the heterogeneous and the process is not home the heat is not moved in the form of the propagated flame. But in case of the gaseous fuel, the flame also gets propagated and heterogeneous combustion also be there. The heat release rate, what you find that heat get reduces as this is the different load condition. As the hydrogen substitution increases, the heat get reduces here. Correct? Now the combustion duration, how much the combustion duration is there? The time duration of the combustion. Combustion duration is how much the time is required for the burning combustion process to be complete. The combustion duration can be calculated from the mass fraction burn curve and cumulative heat release rate. Two aspects of mass fraction burn curve are used to characterize ignition delay, which with the help of the mass fraction burn, we can calculate the ignition delay and also the combustion durations. Ignition delay is defined on the basis of the mass fraction burn curve as the angle between the time of injections and the time at which 1% of the mass fraction burn. Means time of injection we know by the and the difference between the angle of the time of injection and the 1% of the mass fraction burn. While combustion duration is defined as the angle change from 1% to the 90% of the mass fraction burn. So this angle changes from 1% 90% gives the combustion duration. Up to the 1%, it gives the ignition delay. So we can get the both. The cumulative heat release is calculated by an integration of the result of the net heat release rate. The minimum in the cumulative heat release gives the start of combustion. Minimum positions in case of the cumulative heat release gives the start of combustion. During the end of combustion, the heat transfer to the cylinder walls becomes larger than the heat release from the combustion process, which is indicated by a drop in the cumulative heat release rate. Now you will just see about this. Cumulative heat release rate. Now the graph is like this. We go like this and it moves up like this. Correct? Now the combustion duration means what? From this point, the lowest point of this is from this point to this point. Here the drop of the graph takes place, dropping takes place there. So this is the combustion duration. This is the combustion duration. This is the start of combustion. This point is the start of combustion. This point is the 90% of the fuel burn here takes place. 90% of the fuel gets burned here. So this we call the combustion duration. This angle, from this angle to this angle, we call it be a combustion duration. Correct? This is the mass fraction curve. This is the mass fraction curve. Well, I already explained to you earlier. Mass fraction curve gives the ignition delay and the combustion durations. Now the combustion duration, what you observe that in case as the substitution increases, the combustion duration get reduces here. Combustion duration means at a very short time angle, the whole fuel can burn. Because of that, more power output we are getting out of it. Combustion duration. Now we compare the combustion duration with respect to the brake thermal efficiency. Brake thermal efficiency increases here. This is the 80% load condition. Brake thermal efficiency of the pure diesel here, 30% only. The brake thermal efficiency increases beyond 30% in case of the 80 in case of the hydrogen engines. And this hydrogen substitution at the 80% load conditions. And combustion duration, it reduces here. Means when the combustion duration is low, my brake thermal efficiency is more. My combustion duration is low, my brake thermal efficiency also get increases. This is the correlation between the combustion duration and brake thermal efficiency. If the instantaneous combustion takes place, my brake thermal efficiency is very, very high. So this shows that hydrogen has a what the reason is. Hydrogen has a strong buoyancy in the diffusivity. Correct? Then the LPG has a lower flame speed. The combustion process in dual fuel diesel engine depends on the spray and the ignition characteristic of the boiler diesel fuels and the type and overall concentration of the gaseous fuels. The combustion energy release characteristic in a dual fuel diesel engine reveals throughout the relatively complex physical and chemical interactions. In the case of the dual fuel, it has the complex physical and chemical interaction that takes place between the combustion process of the two different fuel systems. However, the chemical kinetics of the diesel fuel and its chemical interaction with the gaseous fuel components are too complicated. Chemical kinetics of the diesel fuel and the chemical interaction with the gaseous fuel components are too complicated, and at that moment it is not clearly understood how the chemical kinetics takes place inside the cylinder. Now, the last part is the conclusions. When we use hydrogen as secondary fuel, substitution of the diesel by 30% hydrogen in case enhances the brake thermal efficiency by 17%. When brake thermal efficiency enhances by 17% when you use hardly 30% of the hydrogen. We substituted only 30% of the diesel by means of the hydrogen. We get 17% more efficiency than the diesel engines. At low conditions, of course, brake thermal efficiency is low. At higher low conditions, because of the knocking problem is there. So brake specific energy consumption at case 2 is low, is light load more. Severe knock was observed. Maximum rate of pressure increases initially at an outload pressure, later on reduces. Net heat release rate shows 3 phases of combustion. This is the unique features of the dual fuel diesel engines. The of combustion in case 2 is less than the case 1 on pure diesel. case 2 diesel plus hydrogens. Net release first phase of combustion is less than the this case 1 operation due to higher premium. Exit delay at low load condition is more. Exit delay is less in case of the higher substitution of the hydrogen. At 80% load condition and 50% hydrogen substitution, the combustion duration is reduced by 5-degree crank angle. It is less than 5-degree crank angle than the diesel operations. So this is the advantage of this. So this is my presentation. Sorry for the what are the electric problem I face. So if any questions are there, you may ask any doubts or any questions.
Yes, sir. On behalf of my friend Vineet Modi, he has asked a question. The question is, what changes is required in engine design while using for dual fuel with hydrogen?
Basically, we do not have to modify anything in the hardware of the engines. We only inject the hydrogen in the inlet manifold of the engine, where air it goes inside the cylinder. Along with the air, we are supplying the hydrogen inside it. So we do not need any modification in the engine as such. Further, any more?
Yes, sir. One of the faculty, Mr. Nityam Oza, he has asked 3 questions. The first question is, please explain cylinder pressure rise for pilot and main fuel on PCA diagram.
Just a moment. Yeah. Now just see that this is the cylinder pressure which is developing inside the cylinder. This is the crank angle, moment of the crank inside the cylinder. Now you observe that these indicate the things to delay. The drop in this ratio thing. And you observe that the pressure can increases. Pressure can increases. This is the conversion of the fuel. The pressure you observe that the pressure is here 360. 360 is the top pressure proportions. Correct? Here 320 is the piston is on about to reach to top pressure proportion. It is in the process. The compression process is going on. The second phase of the combustion is the second process of the combustion is going on. Second is that the compression process is going on here. We supply the fuel here by 340 to 343 degrees and degree angle. Then after this, what ignition delay happen, then the combustion takes place. The peak pressure is up to this point. This is the pressure interface line. In case of this hydrogen, if the percentage of this is there, you observe that the peak cylinder in case of this is more. The fuel is the 10%, 20%, 30%. The peak cylinder of the diesel is low. This is the diesel. Black one is the diesel one. This the color one is the hydrogen, substitution hydrogens. Same thing here. Correct? While in case of the 80% load condition, what you observe that the cylinder pressure in case of diesel is more and the cylinder pressure developed inside the cylinder with the hydrogen is less. Correct? If the more cylinder, you observe that sometimes you observe that the noise is coming out from the diesel engine. If you compare the petrol engine and the diesel engine, this is only because of the pressure rise takes place inside the cylinder during the time of the previous combustion. Whatever the sound is coming out from the diesel, you already observed that the diesel engine gives the more sound as compared to that of the petrol engines. That is because of the higher pressure developed inside the cylinder during the time of the previous combustions. Now, what we observe here that the cylinder pressure in case of the diesel is this much, while at the higher load condition, this is the hydrogens. This is also along with the hydrogens. Is also along with the hydrogen, the pressure is less than the diesel engine. The advantage of this is that engine is really smooth, the sound is developed, the pressure developed inside cylinder is less. Because of the sound also become less. We do not identify the sound because of the better combustion process, better combustion process and the lesser rise in the cylinder pressure. Correct? So this is the cylinder pressure in bar. Yeah, because up to 100, the cylinder pressure is there. Around nearby 100, the cylinder bar pressure is there. What about this nearby 80? So much gap is there in the pressure rise tester inside the cylinder. Any further more, sir?
Sir, one more last question by the same faculty, Mr. Nitya Moza. He says, what is the research state to address metal embrittlement fuel
Sir, I'm
in
not getting
IC
you
engine?
clearly, sir. Can you explain me again? Can you? What is? Sir, I'm not
Sir,
getting you clearly. Can you explain me the question again?
what is the research state to address metal embrittlement due to hydrogen fuel in IC engine?
What is the?
So metal
Research-
embrittlement. Metal embrittlement.
Sir, agree, sir. We have to test the engine after this. I have not check it, sir. After the engine operation, I have not checked the different components of the diesel engines. So at this moment, I am unable to tell you. But my question is, my just word is that since from the so many years I am using the hydrogen in the same engines, no failure of the engine takes place till date.
Okay, sir.
So
Thank you, sir.
since from the 8 years I am using the hydrogen in the same engine continuously without overhauling the engine at all.
Okay, sir. Thank you, sir.
So it does not make any effect over it. I mean to say that it does not make any effect.
Participants, do you have any more questions? You can write in the chat box. I can forward it to the speaker. So I believe there are no more questions.
Okay,
So
sir.
on
Thank
behalf, on behalf of PBIT family and on behalf of all the participants, I take this opportunity to express my sincere gratitude and thanks to Mr. Devdas Lata, who has enlightened us with his topic on hydrogen as a secondary fuel. He has covered a lot of topics like clean and green energy source, concept of dual fuel engine, CRDI, then MPFI, multi-point fuel injection, ULSD and all. He has given basic difference between auto engine and diesel engine. He has covered a real lot on science of combustion in greater detail through many slides. He talked about burned and unburned gases, fuel, ignition delay period, and also told us something about thermodynamic analysis of compression process. Unfortunately, due to technical glitch, there was discontinuity in the presentation. We didn't had any control in such situation. But I'm sure faculty teaching combustion and thermal engineering would have enjoyed the session to the fullest satisfaction. Once again, I thank you, sir, for your presentation at this FDP. Thank you, sir.
Thank you, sir. Thank you. Thank you.
Thank you very much, sir. Thank you very much.
Thank you, sir. Thank you. Thank you.
कौन है?
Yes, Soni sir. Soni sir.
हाँ बोलो.
Yeah, you can conclude today's session and we can end the day here, right?
Yes, definitely. Tomorrow at 10 o'clock, right?
Yes, sir.
Okay.